Hey, hello everyone. So, welcome to another LeetCode video. So, today is probably day 17 and week 3 of this LeetCode challenge. So, today's problem is number of islands. So, I am solving this problem basically because it is one of my favorite problems to do because by doing this problem, it is a very fundamental problem whenever you are trying to learn like uh, graph algorithms or like pathfinding or graph traversing algorithms. So this problem is one of the base problems which you must do before learning the advanced topics like Dijkstra's algorithm and Prince-Kruskal. So this is a very good example which you can do to learn the DFS algorithm or rather BFS also. It's just a graph search problem. So let's go through this problem description once. So given a 2D array or 2D grid map of ones and zeros. So here 1 is denoting land and 0 is denoting water. Count the number of islands. An island is surrounded by water and is formed by connecting adjacent islands horizontally and vertically. And you may assume that 4 edges of the grid are also surrounded by water. So what it basically says is, let's suppose for this example, here it consists of only one island. Why is that? Here all these adjacent ones horizontally and also vertically, like this one and this one and also this column, they are all forming one structure. So that's why this whole thing is forming one island. There isn't any one which is all the way surrounded by water or all the way surrounded by zeros. If there is water or zero in left or right of this one, but it has land on the top side, so that's why it belonging to this uh, set of one. So that means the whole thing consisting of only one island. So let's go through this example. Here this corner 4 ones forming one island and these two forming one island, so total 2 island, and this single one is forming one island because it has water all over it, like left, right, top, bottom, it has zeros. So to make it clear, so let's look at this example over here. So here we can see again these 4, these 2, these 2, these 2, this total thing forming one island, and this one island is also having connection with these two ones, and this one is also having connection with these two ones. So the total thing forming one island, and over here these 4 forming one island, these 2 forming one island, and this one forming one island, so total 3. So how we are going to solve this? So now let's observe the intuition behind the solution, which I'm going to explain right now. So first of all, it has two-dimensional. It is a two-dimensional matrix, so we have to go through each element of this matrix. So that's why we will obviously having 2 for loops, and we are going to traverse through each element. So the basic idea of solving this problem is whenever we encounter 1 in this matrix, we will do what? We will check right side, left side, upwards and downwards, and in this 4 direction if there is a 1 or not. So if there is a 1, we don't want to calculate all the ones as each island. If they are corresponding to 1 like if we are considering this one, so we are not going to take this one as a single island, this one as a single island, or this one as a single island. So we are going to consider what? This whole thing and this as a single island all over, all together 1. So that's why, to make sure that we don't count each one separately, so whenever we encounter 1, we will make sure that all the respective ones in the right, left and top and bottom, we will make them to 0, or rather we can think of it like any value except 1. So for the time being we will make it 0. So first of all, for the first iteration of the loop, we are here, so we encounter 1, so we call our recursive function. We see that it has 1 in the right side and 1 in the bottom, so we will make it 0, and here also 0. And also because we are considering this one, so we will also make it 0. So this one is also again called the recursive function, so it has also 1 in bottom, so make it 0. So make it 0 because it also has 1 in the right side. So this one again called the recursive function, so it has 1 in the right side, so make it 0. but it don't have anything or rather 1 in the bottom, so it don't have to do anything. But for this one it has a 1 in the bottom, so make it 0. But in the left, right and top it doesn't have anything. For now this value it has a 1 in the below, so make it 0. For this one it has a 1, so make it 0. So this whole thing now becomes 0 0 0. But how many times our counter getting incremented? Only once. Because one, why? All these ones are connected to each other. So it will be more clear if I do the same thing for this example. Now, first of all, we are here. We called our function, so make it 0. In the right side, we had 1, so make it 0. In the left side, bottom, we have 0, 1, so make it 0. So for this example, we have 1 in the bottom, so make it 0. Now it is done. For this one, we don't have any one surrounding it. For this one also, we don't have anything surrounding it. It has one, but it is diagonally, not in the top, bottom, or right or left. So this 4 considered as 1. So our counter incremented by 1. So now we are going forward in the loop. This is not 1, this is not 1, this is not 1. So we go through this row also, we don't get any 1. So after that, in this row we get 1, so 1 1. So but this one doesn't have any 1 value in left, right, top or bottom. So for this particular one, we make it 0 and increase the counter by 1. So we found 2 islands. Now again, traversing the array, no 1, no 1, no 1. We found 1. So we have 1 right to it, so make it 0. We don't have anything top or left to it, so make it itself 0, and these two becoming 1 island, so increase the counter once again. So it is 1 1 1 3. So that's why the output is 3. So I hope you got the recursive idea, like how this recursive function is going to work. So the basic thing is, for each one we are going to check all the 4 direction. If there is a 1, you can think of it like kind of I have already considered that island, so that it could not be counted twice, so that's why make it 0. Or rather, you can think of it like we are sinking the island. That's the intuition I want to give you. So let's look into the code so it will be more clear. So this is the code for the solution which I have explained. So first of all, we are doing an error checking, like if it's the length of the grid is 0, then return 0, no island is there. So first of all, we are initializing a counter variable called num islands with 0, and we are doing a nested for loop. So here, if we encounter any 1, we are going to call this DFS function, and we are going to increment this num islands by this much. So in this DFS, we are checking if the ith value or the jth value is going out of bound or not. Like for this example, if ith value is less than 0, which means what? It is going upwards out of bound. If ith value is greater than n or equal to n, so which means it is going out of bound in the lower direction. Or similarly, it is for the j. If it's greater than n, then it is going out of bound for right direction, and if it's less than 0, then it's going out of bound in the left direction. So this is the error checking part. So that is why I have written these 4 lines. And last of all, we are checking if the current element is 0 or not. So if the current element is 0, we don't have to count it, because 0 is water, so we don't need to count within the island. So that's why we are returning 0. Except this condition fails, this is the base condition of our recursive function. We are going to make what? Make the current grid element 0, which we have been doing. Like if this was 1 and this was 1, so if we are checking this element, what we are doing, like if the right of its right element of it was 1, then we were making it 0. So that's why we are doing this line, like making it 0 and checking for the right, left and top and bottom, and calling the DFS function recursively. And after the completion of the whole recursive function, we will return what? 1. Because what? Why? Because every time we encounter a value, like 1 has a right value of 1, so that means we have to make it 0 and increase the counter by 1. So after the whole thing ends up, the grid will look like this, only consisting of zeros, and the recursive function only will return the how many islands we have encountered so far in this grid. So that's why we are incrementing the num islands value with this DFS, with the return value of this DFS function, and after that this value is returned by this function, and we are getting the output. So let's check if it's working or not. Run code. So it is getting the right answer and submit and accepted. So this is how you have to solve this num of island problem. So talking about the time complexity of this problem, the time complexity of this problem would be order of n square, because we are going through each element once, and this is a 2D grid and we are using 2 for loops, so that's why order of n square would be the time complexity, and that is how we are going to solve this. So thank you for watching. Hope you understand what I have said, and do stick around for more videos like this. Thank you.